Alright, so now in this one, just like we did in assembly, we used to display values between 0 to 9 using 7-segment display. So we are going to do that this time around. By that time, we are using AVR ATmega 32 microcontroller, but this time around you'll be using an Arduino microcontroller. And maybe before I begin, I should make mention that Arduino microcontroller is actually powered by an AVR ATmega 328P microcontroller. And you know, the Atmel, as a company that makes AVR microcontroller, are the same ones that makes PIC microcontrollers. So you know, these microcontrollers are linked somewhere, and if you understood or if you take time to learn assembly language, it will make it so easy for you even to learn higher level languages like C, C++, like the one you're using, and these other variable high level languages. Okay, so the microcontroller that sits on an Arduino is actually the microcontroller that you use to program in ATmega Studio using the AVR assembly. Now, because that microcontroller sits on Arduino board and it is now integrated with other digital pins and other peripheral components, even the programming now becomes more simpler. You come and use a higher language of programming, which is C++. Okay, so let's not dwell there. So in this tutorial, we are going to program an Arduino microcontroller such that it will be able to display values between 0 and 9 on a 7-segment decoder. Alright, so if you wanted, you would have used the for loop here in order to declare all these pins, but we wanted it to be unique because we would have just used A in for loop and maybe say for as long as A is less than maybe a certain number, let's say 11, from 2 to 11, or we say from 3 to 11, then all of those should be integers and, you know, would have declared them. But now we want this to be specific so that when you look at A, B, C, D, E, F, G, D, P, this tells you to say that we are talking about the segments on the 7-segment decoder or on the 7-segment display. All right, so A will be connected to 7, B will be connected to 6, C will be connected to 4, D will be connected to 11, E will be connected to 10, and F will be connected to 8, and G will be connected to 9. And we have got a pin that we call a DP. Okay, this is like a drive point, all right, or a control point, okay, of the 7-segment display. Oh, sorry guys, I've got a class scheduled for Amazon IoT class, but anyway, I'll join later. Okay, so like I was saying, so after we do that, we have got this void digital, void segment display digital. So under here, we are trying to initialize that digital, right? A high, like we're turning everything high, all right, under this. Okay, so what is this section? So under this section, what you're actually doing is after you just initialize all of what you have here, then the next thing that you do is like, how do you display 0? It's by turning on all the segments on the 7-segment display, and you do it like this. Then how do you display 1 is by like the first thing that you need is to do your binary calculation and then understand to say, in this case it's even more simpler because you only look at the pattern on your 7-segment decoder and see if this segment is turned on and this is left off. I'm going to have a particular shape, and this shape will be corresponding to a particular number, and that's so you turn on that, you turn on there, and 3 and 4 and 5 and 6 and 7 in the similar manner, 8 and 9 itself. Now we begin the program. So what's going to happen is that we are applying a for loop in here. We are saying that under the void setup, we try and define the variables. So we are going to say that int I, so we have defined I to be an integer. Then we say for I, okay, equal to 4, and for as long as I is less than or equal to, so in this case we have also included 11, so it's starting from 4 to 11. So this is how you apply a for loop. First, you define the variable that you're going to use in your loop, and you're saying that it's an integer and the variable is I. Then you say for as long as this I is equal to 4, okay, and this I is less or equal to 11, then you say pin mode I output. So you are saying between 4 and 11, you have declared all these to be outputs in terms of the pin mode. All right. So if you come here, you see that from 4, 5, 6, 7, and the maximum is 11, and all of these are output, and this is basically what you have done. What you have avoided here is to keep on saying like A output, B output, C output until we finish. We can do that simply by using a for loop here. All right, like the way we have done there. So the next thing, now you come into void loop, and guys, as we have been discussing this, we have said that the code structure in Arduino IDE using the C++ or C, it follows the same structure every time, and the structure is that under the void loop you put the code that's going to run repetitively or repeatedly. All right. So if you see here, we're going to say that digital 0. You have already defined what digital 0 is here. You have already defined what that is. You have already defined what that is, and then you have already defined that on top here. If you come, you have said void digital void. This is a function where you're going to be displaying a 0. So now coming down here in our for loop, what we are actually doing is that when you call that function digital 0, you are saying segment display digital 0. Okay, you put a delay. So it's under here where you put on top there. You are just trying to initialize on what's supposed to happen when 0 is supposed to be displayed, and you said that all of them should be high if 0 is supposed to be displayed, and under the function digital 0. And if you notice, we are calling it as void digital void. Why we do this is like when you're defining a function and telling it in advance what's supposed to do, you use this format. So in this case, we have already said what should happen under the function digital. Everything should go high. So you use this structure like void digital void, such that when you come and call this function, this is going to happen. Excuse me. So if you come down here, you see that we've got digital 0, and we put a display. So as soon as you call the function digital 0, it is going to execute all of this. All of this will be executed, and the 0 will be displayed. Similarly, when you call a function digital 1, it is going to display all of this. All of this will be executed, and then a 1 will be displayed, and so on and so forth, with a similar delay time, which is in this case a 1000 milliseconds, which is basically a second apart. So guys, this is how you can be able to display values between 0 and 9 on your 7-segment. And oh, I made a mistake here. This is supposed to be a 9. All right. Thank you guys, and you can try and play around with this project and see how it can work for you. And by the way, we can compile this together and try and see how it works well for us. Alright, let's see, it's compiling. It's trying to compile. Oh, and I should mention something. If you are new to Arduinos, the program or the code that you write in Arduino, we call it a sketch. That's why you see when it was compiling there, it did not say program compiling, but it said the sketch compiling, and it's saying down compiling and distating. So the sketch uses this amount of memory from the program space, and maximum is that, and global variables uses 9 of dynamic, which is the RAM. So when you program this, when you load this information into your microcontroller, and specifically this information we're talking about here is the ATmega. It's the ATmega 328P, okay, AVR microcontroller is the one we are talking to in terms of these memory spaces, not the Arduino, no. So the sketch we're talking about, the program, the ROM, is about 4% that has been consumed by this code, and the global variables uses about 9 bytes, just 9 bytes of dynamic memory, which is the RAM in this case, and leaving, if you remember, the RAM for, it was about 240 and all that stuff, if you remember your ATmega class. Alright,